This week brought major developments across two of Tesla's most ambitious projects, the Optimus humanoid robot and the Cybercab robotaxi program. Optimus Gen 3 hand redesign. Elon Musk confirmed that the previously revealed Optimus Gen 3 hand design has been scrapped. The patent, which drew widespread attention for its sophisticated tendon-based actuation system, described a mechanism closely modeled after the human hand. Rather than placing motors inside the hand itself, Tesla had moved the actuators to the forearm to reduce weight. The design featured 22 degrees of freedom with 4 degrees per finger plus 2 at the wrist, and used 3 thin control cables per finger routed through integrated channels to enable precise, independent movement. On paper, it was an extraordinary piece of engineering. Musk had even claimed the design would allow Optimus to play the piano. However, when tested under a demanding real-world and simulation conditions, the finger joint mechanism proved unreliable. Problems like friction accumulation, cable wear over time, and the sheer complexity of assembling such a system at scale made it unworkable for Tesla's goal of producing millions of units annually. Musk addressed this publicly on X just days after the patent became widely known, simply stating the design had already been changed because it did not work. Despite this setback, recent video footage believed to show the new Optimus Gen 3 hand has impressed observers with its remarkably human-like finger movements. The overall body design of Gen 3 has also been overhauled, now featuring a smooth, seamless black outer shell that conceals all joints and internal components, giving it a cleaner and more streamlined appearance. The shoulders and hips appear more rounded, and its overall posture looks noticeably more natural compared to earlier versions. Musk had previously acknowledged that manufacturing Optimus at scale will be one of Tesla's greatest challenges, which is why each design iteration needs to prioritize not just performance, but also production feasibility. Optimus Gen 3 may currently be in its final prototype phase, with a potential reveal expected this quarter after originally being planned for earlier in the year. Musk confirmed the robot has already been walking autonomously inside Tesla's facilities, but still needed refinements for a public debut. The hand alone represents more than half the engineering difficulty of the entire robot, and the demands for Gen 3 are even higher than before, requiring fingers that are simultaneously flexible, strong enough for gripping, and durable enough to function continuously through long warehouse or factory shifts. Optimus at the Boston Marathon. While Gen 3 continues development behind the scenes, the current Optimus 2.5 made a public appearance at the Boston Marathon, stationed at a showroom along the race route near the finish line. The robot performed simple, crowd-friendly actions such as clapping for runners, distributing water bottles, and gently engaging with bystanders. On the surface, this looks like a marketing event, but it serves a deeper engineering purpose. Every interaction in an unpredictable, crowded, high-noise environment generates valuable real-world data that feeds directly into Tesla's end-to-end AI training pipeline. The fact that Optimus can maintain stable operation in such a chaotic setting reflects meaningful progress in its sensor systems and artificial intelligence. That said, the robot's current limitations were also visible. Movement remains noticeably slow, with a delay of roughly half a second to over a second between sensing an input and responding to it. Actions like reaching for a bottle and handing it to someone happen at a pace that still feels mechanical and hesitant. Tesla appears to be deliberately trading speed for safety and precision at this stage. Optimus 3 is expected to address these shortcomings significantly. As Musk confirmed, it will run on Tesla's next-generation AI-5 hardware, along with several other major improvements. Robotaxi expansion, and Q1 earnings. Tesla's Q120 26 earnings call delivered a substantial update on the robotaxi program. Paid robotaxi miles nearly doubled compared to the previous quarter, signaling growing real-world demand. Unsupervised robotaxi service, meaning no safety driver present, has now expanded beyond Austin into Dallas and Houston as of April. No accidents or injuries have been reported in connection with this expansion so far. The fleet is currently operating on software version 14.3, which includes a significant architectural upgrade deemed safe enough to eliminate the need for human supervision entirely. Cybercab pilot production has begun at Gigatex this month. Musk cautioned that the ramp will start slowly before accelerating sharply toward the end of 2026 and scaling more aggressively through 2027. Cybercab is intended to gradually take over from the Model Y vehicles currently serving as the robo-taxi fleet, eventually becoming the primary vehicle in the network. Both Cybercab and Tesla Semi remain on schedule for volume production in 2026, with heavy investment flowing into AI computing infrastructure and new manufacturing capacity. Tesla's broader goal is to have robotaxi operating across roughly 12 states by the end of this year. A next-generation software update, version 15, is anticipated in late 2026 or early 2027, built around the AI 5 chip and designed to push autonomous driving safety even further ahead of human drivers. Robotaxi revenue remains modest in 2026, but is expected to become financially significant starting in 2027, and Tesla has identified the service as its most important long-term recurring revenue platform. NHTSA crash, data and transparency concerns. The National Highway Traffic Safety Administration recently published incident data covering autonomous driving systems from multiple operators. Through approximately mid-March 2026, a total of around 825 incidents involving fully unsupervised Level 4 robo-taxis had been recorded across all companies. Waymo leads this count with 697 incidents, followed by AV Ride with 41, Zoox with 32, and Tesla with 18, of which 15 came from its Austin-based program. These numbers require context. Waymo operates large fleets across dense urban environments including San Francisco, Phoenix, and Los Angeles, where exposure to complex traffic situations is far greater. The majority of Waymo's incidents involve other vehicles striking its cars while stopped, which reflects the behavior of surrounding human drivers rather than failures of the autonomous system itself. Tesla's program, by comparison, remains relatively small and geographically concentrated, which naturally produces fewer reported incidents. The NHTSA data also only captures incidents where the autonomous system was actively operating without supervision, excluding all supervised FSD miles. Looking at the types of collisions, Waymo's incidents predominantly involve passenger cars and SUVs, consistent with the high-density environments it operates in. Tesla's incidents show a higher proportion of collisions with fixed objects such as poles, walls, and curbs, which some analysts connect to the challenges of a camera-only perception system in judging distances or detecting stationary obstacles. In terms of severity, the data is generally reassuring. 16 of Tesla's 18 incidents resulted only in property damage, with 2 causing minor injuries and 1 requiring hospitalization. Waymo's larger dataset follows a similar pattern, with the vast majority of incidents being property damage only, though it also recorded 23 hospitalizations, 51 minor injuries, and 1 fatality across its much larger operational history. One significant point of criticism concerns transparency. Waymo and Zoox provide detailed written accounts for each reported incident, describing what occurred, how the system responded, and what other parties were involved. This level of disclosure helps regulators and researchers identify patterns and improve safety standards. Tesla, by contrast, has fully redacted the narrative descriptions for all 18 of its reported incidents, citing potential confidential business information. While NHTSA permits this, Tesla is the only operator applying it so uniformly. As a result, the public cannot determine fault, assess system behavior, or understand what specifically went wrong in any of Tesla's cases, which has drawn criticism from safety advocates and observers. Cybercab production. Progress drone footage has shown dozens of completed Cybercabs staged at outbound lots at Giga Texas, including finished units without steering wheels, marking a notable production milestone. Tesla is actively expanding assembly lines, adding workers, and installing new equipment with the aim of building hundreds of vehicles per week in the near term. Some reports indicate over 60 Cybercabs have already been spotted at the facility in various stages of completion. Testing has also extended beyond Austin into surrounding areas. The current Model Y robotaxi fleet has reached a point where between 13 and 27% of trips are completed fully without human supervision. Significant challenges remain, including regulatory approvals across multiple states, compliance with varying local laws, and the ongoing task of building public confidence in the technology. Experts anticipate some delays tied to safety reviews and approval processes, but Tesla continues to invest heavily in the infrastructure needed to scale. Looking ahead, taken together, the broader picture from NHTSA data suggests that robotaxis across all operators are still in an active learning phase. Higher incident counts from larger fleets primarily reflect greater operational exposure rather than fundamental safety failures, and the overall trend toward minor, property damage-only outcomes is encouraging. For Tesla specifically, the shift from a Model Y-based fleet to mass-produced Cybercab represents a genuine turning point. If the company can sustain a low incident rate, improve its public transparency, and successfully scale production, Cybercab has the potential to meaningfully reshape how people move through cities, offering a cheaper, safer, and fully driverless alternative to conventional transportation. The rest of 2026 will be closely watched by both investors and the public as production numbers, real-world performance, and upcoming software updates will all serve as critical tests of whether Tesla's autonomous vision can be translated into reality. Sonnet 4.6